Okay, welcome back everybody. We're in week 8 already. Hope you had a nice relaxing week last week. We didn't do too much. We went over some information, but we didn't have too much work to do. This week we're going to start in on intrusion detection, which is a big part of physical security. You want to be able to detect things that happen at your site, and there's a couple of ways you do that, obviously with cameras, which we'll go over starting next week. But one of the best ways is through an intrusion detection system. So what exactly is an intrusion detection system? So an intrusion detection system, or commonly in industry called an IDS, is an alarm system. And you'll hear people call them alarm systems too. But they do so much more than alarms that that's kind of a misnomer now with modern technology. But they detect intrusion. They tell you when something has happened that should alert you that someone has breached your building or your perimeter. A lot of times they're integrated with the access control, and they run on the same control panels. So inside that box on the wall that has the panels, right, the field panel, the control panel we have that we hook our readers to, right, we have a 2-reader panel that we're using. There's another board inside, another printed circuit board, that you connect wiring for inputs and outputs for your alarms. So they can run on that same apparatus in that same box and integrate all together, and that's kind of important, and we'll talk about how that works. Or it can be a standalone. You can have an access control system, and you can have a standalone alarm system that reports in separately. They can be silent, right? Silent alarms. You open the door, the alarm trips, no horn goes off, no lights flash. Bank alarms, silent alarms, right? They can be audible, loud, big horns and bells, or they can be both. You can have it be both silent, as in reporting to somewhere, and audible as a bell goes off. A silent alarm has to be monitored really to be effective. Audible is minimally effective if it's not monitored. You break into something at night and a big bell goes off. You break into a car and a car alarm goes off, right? That tends to make people run away because they don't want to draw attention to themselves. But no one's really going to know it if you get in real quick and you disable that alarm. A lot of times people won't even, they'll hear car alarms now. They just, don't even look toward that way because they're so heard so often, especially in cities. So a silent alarm really has to be monitored. Somebody has to be watching for that alarm to come in somewhere and report to them so that they can send a patrol or have some kind of response. But audibles can be minimally effective if they're not monitored. But again, how often does somebody really take notice of a car alarm these days? So really, for industry, there are two main types. An integrated alarm, right, that runs on that access control panel, same system, and they tie in with each other. And the great thing about that is that if our access control system is working properly and I run my badge and it unlocks the door because I'm allowed to get in there, once it unlocks the door, it turns off the alarm for a certain amount of time till I can get through the door. And then when the door closes again, it rearms itself, and that alarm is now set to go off if somebody tries to get in with a crowbar after me and not use a badge. So having it integrated has a great advantage that way. It's also pretty cheap because you've already got your infrastructure in there because you have access control. You've already purchased the panel. The board is pretty inexpensive. You're just running wires at that point. The standalone, though, has its own uses, and it's used a lot in smaller businesses. It's used as a secondary reporting. And you would recognize these alarm panels because you probably have seen them if you worked in a store anywhere or if you had a home alarm system. And think home alarm. Think of that ADT box on the wall, and I'll show you an example of it. That's really the secondary type. Not used as often in industry, although there are many alarm companies that try to sell those because they're easier to install. And if you don't have an access control system, that's what you're going to use. So let's talk about the two different kinds. We'll start with the integrated, and then we'll work our way over to the standalone. So integrated, it's really pretty easy, actually. It uses a door position switch, also known as a reed switch, a balanced magnetic switch. I think that's what the textbook calls them. They've got a lot of titles, and there's a lot of different kinds you can use. But basically it's a switch that when the door is opened, when the door separates from the frame, it says that something has happened, right? And it reports back through the wiring to an alarm board in that control panel, which sends an alarm to the person sitting at the host. So the person sitting at the host who is programming in access badges, like we learned last week, is sitting there, and then all of a sudden something pops up and says, hey, someone just breached the back door. Because the contacts separated, the switch separated, and it caused that alarm condition. When the door closes, normally that will reset the alarm, and then you'll get a secondary notification saying the alarm's been reset. So it's pretty basic. It's just that if the door opens, if the switches separate, send this alarm in through the panel, and it's a narrative that comes across the host and says, this is what just happened. Somebody just broke in the building. From our old wiring diagram, our riser diagram that we used the last few weeks, we just added in up top here. Those are pretty big, but they're there for, for purposes so you can see them. But on each door, you see there are alarm contacts. There's a switch on the top and switch on the bottom. And when these separate, it sends information to here, right? One of these boards is opening and closing the door. The other one in here has wiring for alarm inputs. And it says, if these separate, send a message back to the host to tell them that someone has breached the door. They've opened the door not using a badge. If you use a badge, remember it goes back up, you use the badge, it goes back up here and it decides whether or not you should get in, and then it comes back down and opens the door or doesn't open the door. Well, it does one more thing when you've got it integrated. It also tells this alarm panel, this alarm board, don't send the alarm in because I'm deciding whether I'm letting this person in legally, and therefore if it's a legal entry, then it will not send the alarm in, and the alarm will reset when the door closes. It could also be set to say that if someone runs a badge and it comes up here and I say, no, this person is not supposed to get in the room, then send in an alarm saying we have someone who's trying to get in the room that shouldn't be. The alarm contacts haven't separated in that case. It's a matter of the reader telling the panel, we've got somebody trying to get in here that shouldn't be. And basically it sends that information back to the host too and says, someone just ran a badge. It's not a good one. A lot of times we have it set so that you can pull the person's face will pop up and their identity. And you can, again, tie that in with other things. And we'll talk about cameras coming up here where you could actually tie it into a camera and have it click on it so you could see what was going on at the door. But the alarm panel does a couple things. Separate the switches, send a message to the host, say the door's been breached. A badge is used. Badge is good. Send a message to the host, send a message to the door contact, send a message to this panel. Don't send an alarm to anybody. This is a good entry. You don't need to do that. And if someone runs a badge that shouldn't be, sends it up here, says, no, we're not going to unlock the door, and we're also then going to trip the alarm and say somebody's trying to get in that shouldn't. So it's pretty basic. It all takes place in the same panel, just on different boards, powered through the same battery backup, powered through the same power supplies. Everything else that we had in place, you just need to add a board, and normally when you put the panel in, it comes in the box. It's pre-mounted in the box. So I won't say it's a free system because you have to put in the contacts and the wiring, but it sure is an inexpensive way to go. So those alarm contacts, those read switches, the switches that open and close when the door opens and closes, really what are they, right? They're called a lot of stuff. You'll hear them just referred to as contacts. They're a type of switch, and I'll show you how that switch works in the next slide. But they report an open or closed position using magnets or plungers. Something changes. There's something that opens and closes, essentially, to say that there's been a change in the condition. Now, the magnets we'll talk about are balanced, and that means you can't just use any magnet, because otherwise you could just shove a refrigerator magnet between those two contacts and open and close the door with a crowbar and the alarm would never go in. And I'll show you how that works. They need to be supervised. In other words, you've got to have something in the system that tells you if somebody cuts the wiring to try to disable that alarm. You can't just have it sit there. Otherwise, you could just knock the contacts off of a door and you could come and go as you please, right? And they can be either surface mounted or recessed mounted, and there's good reasons to use both. So here's a couple surface mounted contacts, and if you go around Slippery Rock, if you go around any industrial building that has an alarm system, you will see these mounted on the top of the door, normally not on the hinge side, but on the swinging side of the door, toward the top, right on the edge where the door frame meets the door. And you'll see this one mounted on the door, and this one with the wiring, if it's exposed, mounted on the top. And let's see what's going on inside those things. So that part that's mounted on the door, the one that didn't have any wiring, is just a magnet, and it sits on the door. This one sits on the frame, and inside it has two metal reeds. And those reeds are either apart or they're together. When the magnet on the door, the one with no wiring to it, right, is close enough, it's pulling those two reeds together and it's connected. When you open the door, the magnet's not pulling on this one anymore and they separate. They're slightly bent and they separate. And when they separate, that's what sends the alarm in. It's that simple. A reed switch is really a common switch, and you wouldn't think about where you might use it, but think about if Well, gosh, a lot of you have laptops. When you open the laptop, you notice how the screen lights up? It's a reed switch. When the old flip phones, when you opened your flip phone, it knew to open up and start up or to shut down when you close the flip phone, right? It was a reed switch inside. It's not a push button switch of any kind. You couldn't see the switch. You can't look and see a switch when you open the cover in your laptop. It's a reed switch. It's a magnet, and there's one in the top and one in the bottom, and when they separate, it sends a signal to your CPU to fire up and light up the screen and start your laptop. Same principle, easy stuff. The magnet, however, has to be a certain pull, and it has to be a certain orientation. If you think about the magnets, if you turn a magnet the other direction, then it will push things apart. If you have the magnet slightly held up or down or far enough away, it will change the amount of pull. The magnets get balanced based on the distance, and the magnets themselves are matched as a pair, and they have to be equal distance apart. And if you try to use another magnet, you're probably going to have too much pull, which it will detect, or too little pull, which will open it up. So they really are harder to defeat. People talk about, well, they're magnetic switches, so I can just shove a magnet between the two. It's going to hold the reeds in this position. Now I can break in the building. It doesn't work that way. They are balanced. They're tuned, fine-tuned to each other. Very hard to do that with even with another contact, which really won't fit between the two, and it will pull it from a different direction. So they're pretty reliable, and they last for a very, very long time. So really cheap. A set of door contacts like this, door position switches like this, a good set will run you $15. A run-of-the-mill set for a home system really runs the installer somewhere around $5. Really cheap. But they can be broken by carelessness. They're plastic housings. And so, if somebody bangs something trying to carry something tall through the door, think about the things when people are moving into dormitories, and dormitories have these on the doors. And if you're moving in, you're banging the door around, you're banging on this. This is sticking out about a ½ inch from the door frame on the top. This is or from the door itself. This is sticking out from the door frame about the same amount. They're plastic. They're going to get banged up. So you got to be careful with them a little bit. They're not, I won't say they're delicate, but people carrying tall things through a door and not watching what they're doing can really jam these things up. And the wires need to be protected. A good installer will put the hole right behind this and kind of just slip them through. A bad installer will run the wiring up and put a hole someplace else, and you have this exposed wiring, and you need to protect that. There's something called wire mold you can wrap. You can put metal conduit. You'll see metal channels that you can put on. But for the most part, most installers will hide those and make a nice clean installation. But if they're not, those wires are quite delicate, and if you bang them, you will short the system out. So reed switches also come in something called a recessed contact. And this protects the contacts themselves from damage because they're actually recessed into the door and into the door frame. Now you need to drill the door, and I'll show you a picture of that here in a sec, and the frame, and that's about a 1-inch hole. So they're more expensive to install because you're actually altering the door itself, and you're not going to put these normally in a metal door. You're going to put them into a wooden door. But if you go around, even campus, you'll see these, I'm sure. If you look, when you open up a door that you assume to have an alarm on it, if you look, you'll be able to see this little plastic, just a little plastic circle on the opening side of the door on the top of the door frame. You'll look up and you'll see it. And if you reach up on the top of the door, you'll feel this one. And these two are the magnetic contacts that are facing each other with the reed switch going this direction, if you will. And the wiring is completely protected. So basically, to install one of those, you drill in the top of the wooden door. You put the magnet that has no wiring on it. You sink it right down in there. And then in the door frame, just opposite it, in the top of the door frame, you pull through the wiring and that other magnet, and they touch each other essentially, or they're really close to each other when you close the door. And when the door swings open, the reeds pull apart, and the alarm goes in to tell you somebody has opened that door. And again, if you look at a door as you go through that you assume to be alarmed, if you don't see the surface mount contacts, look up in the frame of the door as you go through, and you'll see a little 1-inch plastic circle. And a lot of times you'll see doors that are drilled for them, and the alarms have been removed. You'll just see a hole there. That's what it's from. And then if you do that, then just reach up to the top of the door and feel, and you'll feel the other circle right up in the door, and you'll be able to tell that that is indeed an alarm door. Now for our overhead doors in our warehouse, if you put surface mount contacts on, you know they're going to get banged up mean people are moving heavy stuff through. And surface mounts. And you can't really put recessed because what are you going to do? Drill into the floor and drill into a overhead metal door that really isn't very thick. There's no way to do that. So what you're using is these are heavy duty contacts. In this particular set, this straps to the floor very close to the edge. You can roll over it with carts. It's very heavy duty. And this bolts onto the overhead door. So the magnet here is the stationary magnet. This is the one with the reeds inside of it that will pull apart or stay together. And when the door goes up, the magnet pulls away and the reeds separate, and it tells you someone has opened an overhead door. You'll see these mounted in a couple different ways, and I'll tell you that I have a preferred way, and that is just as I showed you here. But let's take a look at one other way that they can be mounted. So in this particular picture you'll see up on the top, that's the floor mount. Now that one is really for demonstration purposes because they're way too far out away from the edge of the door, and this cable, which is protected in a metal housing, flexible metal housing, is going to get run over and eventually it's going to get damaged. So it's going to pull apart here. So you want this way over to the edge, right to the edge of the door, and this right on the edge of the door that goes up and down, right? This is on the edge of the floor, this is on the door itself, and they sit on top of each other. You will see channel mounts which go into the channel of the door, right? As you raise an overhead door, right? Think about your garage door now. As you raise up a garage door, there are channels on either side the door travels in, and you will see contacts that mount that way. One stays stationary on the channel itself. The other one is bolted to the door, and when the door lifts up, this one goes up. The reeds inside here open up, and the alarm goes in. The issue I have with this is a big apparatus, and normally they're about this big, and they're normally installed. The installer will put them at the most comfortable place for him to put in, him or her to put in. So if the installer is about 6 feet tall, these will be mounted about 5 feet off the ground. It's almost classic because they want to stand up comfortably and put them on. And that's great for the installation, but it's also the worst place for running into things. Things are on forklifts, and these overhead doors, they're built heavy duty, and so are these tracks on the side, these channels, simply because they get hit a lot. Now you've got your sensitive contacts in a plastic housing here, right? There's metal on the frame, but there's plastic housing here. They're going to get banged up all the time. If I were you, I would stick with floor mounts. Let your situation be your guide. When you get out into the real world, you may end up liking these for one reason or another. Your particular application may be better, but I would strongly suggest you use these. I've never seen one of these fail from damage my entire career. They're just built so darn well. Now we looked at all the different types, well, not all the different types by any stretch, but we looked at different types of reed switches, and we looked at the primary ones you would use. But there are also different types of contacts. This is a plunger contact. So you mount this somewhere and a door will come and close on it, right? And pushes this little plunger in. This is just a little ball here that's on a spring, and there's a little switch down here. And when the plunger comes out, when whatever is holding this back, could be on a drawer. These are used on metal drawers. If you want to alarm a file cabinet, a sensitive information file cabinet, you could put one inside. And when the door is closed, the metal lip pushes this back in, keeps these contacts together, and it says the door is secure. And when somebody pulls the drawer open, this stays on the file cabinet frame itself. The drawer opens up, the plunger comes out, and boom, you get an alarm. It says the switch has just changed, right? You could use reed switches inside of these. These normally just have a little metal contact in it. They're simple, and they're easy, and they're cheap, but they have limited applications mainly because you don't want to put them on a door that's constantly opening and closing because they're on a spring. And if you can not use it, you're better off because the spring will wear out with constant use. And these little ball things here can get gummed up if you use them in a door. So they're really good for cabinets. They're good for, heck, you see these types of things when you have cabinets that have lights inside. It's really a plunger switch. In fact, the light on your refrigerator normally, when you open up the door, you'll see a little plunger somewhere. It's the same principle as the light in your refrigerator, really. Cheap, can be used a fair amount, needs to be cleaned, but if you used them on a door that was constantly slamming, your refrigerator door doesn't slam like a regular door does, these would probably get broken pretty quick, but they do have their use, and again, extremely cheap. So what else can we use, though, to trigger an alarm? Well, let's think about the passive infrared sensor. You're all familiar with these because you've seen these light switches. They're going in just about everywhere because they shut the lights off automatically when when things stop moving around, right? You've seen these in the corners of buildings that have alarm systems in them, this one or this one over here normally. Your outside light on your home may have a passive infrared sensor. This is a more advanced one. It really works on the exact same principle. It just looks a little more high-tech, and you would use this in a industrial application. But for the most part, the passive infrared sensor is just that. It just picks up heat, but it does it in a special way. So the passive infrared sensor is just that. It's passive. It is not sending out any signal. The little square in the front here, and actually in this one it's a fairly large square, is a place that picks up signals, but it's not sending out anything, right? It's not shooting anything out to try to pick up movement or bodies. And normally these are called motion detectors, but that's not really what they are. They're picking up heat, and heat is emitted by the body. And on each side of this window, right, the sensor in the front, there's a slot. And it's right now, it's just picking up. There's nothing moving in front of it, so it's picking up a constant temperature. Everything over the 0 Celsius has a temperature reading that these can pick up. So it's picking up the constant temperature of the room. Nothing's changing. If I walk in front of this, I will hit either this side or that side first as I'm crossing the path of this. It now says, wait, there's heat coming in from this side, and it picks it up very quickly, but over here there is none. And therefore, I have something moving in front of me that is, it's picking up infrared heat. So it's picking up the body. So it's read by the two slots and the change in temperature between each side of this window. It's not shooting anything out. It's just taking in information. It's a receiver, so that's why it's passive. It's using infrared heat, and it's measuring the change in heat from one side to the other, normally as someone walks in front of it. So if I'm going to integrate this with my intrusion system, right, my intrusion detection system, I'm not going to put this on a door necessarily. I'm going to put it in the corner of a room somewhere, in an open area hallway, so that I can pick up when someone passes from one side of this to the other, coming from either direction, and it will tell me that something is moving in that hallway. Something creating heat. The problem is that heat is emitted by lots of stuff. Air conditioning units, heat vents, even moving papers on a bulletin board. If you put a fan on it, the heat from one side of that piece of paper to the other is constantly changing because it's moving back and forth, right? It's not staying constant. Fan yourself with a, little hand fan, and you'll notice that you get cool and then warm, then cool and warm, depending on how fast your hand's going, right? Same principle. And because you're changing the temperature, that's why people think it's picking up motion. It's really picking up temperature change. But things like papers on a bulletin board move when the heat comes on, right? So you have a heat vent over on the ceiling that's out of the range. This guy has a range that you can set, right? How wide you want it to be and how tall you want it to be. It can go up fairly high, right? But let's just say that up on the ceiling is the heat vent or cooling vent, either way. And the AC kicks on, and here comes the fan, and it starts blowing around papers on a bulletin board, and they are in this view. They are probably going to set it off unless you dumb this thing down. And there's a setting you can dumb it down. Get it too dumb, it's not going to pick up the movement of people. So they're tricky to set up and keep calibrated, and you have to remember that environments change. You will put one of these things up and you'll get it calibrated and everything's great, and then somebody goes and throws up a bulletin board, or somebody puts a space heater in, or there's any number of things that can trip these. I hate them because they always tend to give me trouble, and when they don't give me trouble, you think everything's fine, and then you test them out and find out they're really not working very well. So they're really, you'll see them everywhere. People use them everywhere. I'm not a fan of these. I would prefer to have some type of switch on a door and know that something separated, know that something actually happened, rather than a lot of false alarms. But passive infrared sensors have their place. Big open areas, hallways where you need to detect movement, or you want to detect if a door alarm goes off, let's just say, and you have a read switch on the door, and then you want it to be able to tell which direction your intruder went. You may have one of these in each adjacent hallway. And depending on which one goes off, the movement of direction of movement of your intruder. They can help you with that for sure. So again, a little tricky sometimes, but very familiar, used quite a bit, and not all that expensive actually. Then we have glass break sensors, and in the text you read about glass break sensors. The one here on the left-hand side is a shock sensor, and it trips based on shock to the glass. So if I throw a big rock at a plate of glass that has one of these, and we call them glass break sensors, but people will generally refer to this type and the one below it here as window bugs. Put window bugs in, right? And it will tell you when the window vibrates. This is down here is another window bug, and I don't know why they did this installation this way. It was so hokey I had to put it in here. You could have just run the wiring through this frame and directly into the wall and met it up here, but for some reason they did this, and it's just one more place where your alarm system can get broken and one more place where it looks ugly and people will complain about it. But these right here are just that. All they measure is the shock and the vibration of glass. Now, this is a dual technology one here, and this happens to be a wireless one. It picks up both the shock and vibration of glass and the sound of breaking glass. So it needs both in order to go off. So I have had these types go off, and they're very inexpensive to install, and you can daisy chain them together so you can have one side of a building, and you hook a bunch of these together on every piece of glass that you've got, and it just says glass break on west side of building. You don't need to know which window it is, because when you roll up with your patrol, you'll be able to see it if it's a broken window. But I have had lawn mowing get these things to trip. A car backfire get these things to trip sometimes. They really do need to be properly tuned and in the right environment. These, on the other hand, are much less likely to give you false alarms or nuisance alarms, and we'll distinguish between the two in a minute, but they're harder to test. How do you know? So what you test these with a stick, essentially. You're shaking the thing a little bit, and then you have a tuning fork that's tuned to the sound of breaking glass. It's really old school. I mean, they make a device that does it, but most security managers don't have those types of devices. You have a tuning fork, and you shake it, and you test it that way. Glass breaks are necessary when you have ground level glass in a high security building, because it would be one of the easiest ways in. You'll also want to have different types of glass, which you read about in the text this week. Very short segment on glass, but certainly enough. But glass break sensors are definitely used. You'll see them when you go into banks, and you'll see them when you go into some commercial buildings on the ground floor, glass only. You wouldn't put these on the upper floors. No reason to, really. I mean, yes, somebody could, I guess, Spider-Man up your building and go in through an upper window, but that's very rare that you will see that. You will see these on the ground level. And normally you will see the shock sensor type. These will be mounted not on the glass, but normally on the ceiling. And you'll see usually a green light and a red light, and you'll be able to tell that that is a glass break sensor, a dual technology, glass break, and a shock sensor. So one final major way that you would get alarms sent in would be a microwave beam. And a microwave beam is very similar to a PIR, to a passive infrared, except it's not passive. So the microwave works on the Doppler effect. The device itself emits a signal. So these two devices would be mounted opposite each other. Depending on the range, they could be up to, I think they can go 50 yards, some of them maybe even more. If you get these industrial ones up top here, they can go long distances. You see these on prisons, military bases, where you've got long stretches of open terrain that you need to understand who goes across the beam, right? And but they emit something. So instead of just reading the heat that's being sent to the device, they're actually sending out a microwave beam, and using the Doppler effect, the change in the wavelength of that beam when it hits something, it will tell you whether something has crossed the beams. Very expensive. Again, unless you're in a military, an airport, a prison, something with a very long distance. I had someone recommend these to me for a facility just last week, and it was only a quarter of a mile. And I used cameras actually on the fence line itself with other technologies we'll talk about, rather than invest in one of these, because the expense was tremendous. I mean, it would have been almost $1 million to put in this, and the value of the resource wasn't as high. And so I decided to go a different route. But these definitely have their place, and you will see them, again, airports, military bases, prisons, where you have long, long stretches of open terrain, where you have line of sight between them, because they need to be able to see each other, and they send out the beam and back and forth, and if somebody crosses the beam, it changes the wavelength and sends an alarm. So those are the primary ways that you can detect for either a door or an outside area or for glass or for an open room, you use the right type of switch. These are all switches. They're really just an on-off. They're telling you something has changed. If this happens, then do this. If somebody walks into between the microwave beams, then send in a signal to your alarm system. If these two doors separate and the reed switch opens up, send in an alarm to my alarm system. It's always an if this, then that type of scenario. Those are the ways you can detect alarms. Those are your switches. So now we know we have alarms and we can put them through. We can put them through our access control panel using the alarm input boards in those panels and have them go right up through the same line as all of our door information, goes right back to the host. And we can monitor those alarms that way. So we'll know that only the right people are going through the doors because our badge information is coming from the host to the panel, back to the door, decisions being made. Now we know we have the alarm contacts going to that same panel, making decisions. It's all integrating with each other. However, what if you don't have somebody who sits at the host all night? What if you don't have anybody that sits at the host at all? You go in and you program badges, but you're not monitoring the alarm, but you still want to know when somebody breaks in. Then you have a standalone system. And a standalone system needs a panel, and in the old days it used to be a dialer. The alarm contact would open up, and it would trigger a device that dialed a phone number, and it had a tape recording device on it, and the police normally would pick it up, and they would say, 911, can I help you? And it would say, this is the ABC store at 123 Main Street in whatever city. Our burglar alarm has tripped. Please send a police car to investigate. Now they're a little bit more high-tech than that. They send all kinds of signals, and normally they're tied in with your fire system and smoke detection and CO2 detection and intrusion detection, all coming through these panels. And if you've seen them before, they're just a panel on the wall. We'll look at one in a second here. But they use the same contact types. So the same inputs, those switches, reed switches, passive infrared, microwave beams, plunger switches, whatever you're using, same type of contacts going into these things, but they wire back, instead of to the access control panel, they wire to something called a Bosch or DMP panel, an alarm panel. It's a little device that anybody who has a home alarm system has seen it on the wall with a little, numerical keypad on it, and for putting your code in, right? And you arm it, and your contacts are activated. And if somebody opens or closes the door, moves in the hallway, whatever you're trying to detect, the alarm goes into them, and then they send somebody or they call you and tell you there's an alarm going off. They can be zoned so that some alarms come on at certain times, some go off at other times. When you put in your code, you put in a different code and you say, okay, I just want, I'm going to go in and work at night in my building, right? I'm the only one. I go in, I open the door, I have a certain amount of time to put my code in, but I put in a code that says arm the outside doors only, but don't trip any of the alarms inside the building because I'm going to be working in here and moving around. When I leave and I'm all done, I put in a different code that arms everything. So they can be zoned. And one of the problems you have with that is that these tend to work on keypads and code numbers that you put in. And again, people write down the code numbers right next to the panels, or they all share a common code. And when somebody leaves the company, you've got to change those alarm codes because someone could let themselves in, even with a crowbar, because they have a certain amount of time to reset that alarm, right? When you have a home alarm, you walk in the house, you have 15 seconds to put your code in and shut the alarm off. Otherwise, the alarm company calls you back, says, hey, are you alive? Which is the silliest thing in the world. I don't know why you'd call the person who's there, because if indeed the alarm's going off, you should just assume there's a problem. They didn't reset it. But people share these codes all the time, so there's a problem with those. But how do they work? So here's the diagram again. And the alarm contacts are coming up, and you see them going here into this panel. And there's a reason I have them going there first and then out to the DMP panel. But you can wire it directly to the DMP, right? I'm calling them a DMP. That is a brand name, but it's just industry jargon. The Bosch panel, the DMP, any alarm installer will call it one of those two things because they're the two main dealers, right? It's almost like, do you want a Coke or a Pepsi, right? If you could run the wiring straight to the DMP panel, and when the alarm triggers, this reed switch opens up, and there's not a good card read, it's been forced open. The DMP panel will then send a signal out, normally through the internet, but it could be through a dialer, to an alarm central station, an ADT station somewhere in the world, right? I mean, ADT is one of the big purveyors of this, but there are many other companies out there that do this type of service, and then they respond to whatever you told them to do. Your instructions may be to call the police. It may be to call the owner and have him go in and check on it. It might be to call a patrol service that you've contracted with that will go over there and check on your building for you. But you can wire directly from the contacts to the panel and back out again, and it never touches your access control system. But that would be way too easy because I like to mix them. And they can be mixed and they can be very effective when there's nobody sitting at the host 24/7. So you could have somebody sitting at the host all day when your building is really active and there's a fair amount of alarms coming in because people are tripping stuff and you forgot to turn something off or you don't have it zoned and there's alarms coming in. But then when everybody goes home, you set the DMP panel and you shut the host down. And then all those alarms are going to go to that central monitoring station where they'll take care of it for you. You place it between the access control system panel and the host, just as I had it in that diagram. We'll look at that again. And it sends a signal to both the host and the third-party monitoring company. And there's a place that this is generally used, and that is where you have overnight guards and high-value materials. So if you have 2 guards and you're guarding, say, a jewelry distributor, right? You've got $10-12 million worth of diamonds at any particular time, and you've got 2 guards in the building at night because you want to make sure that you're protected. Sometimes those guards go bad, and the one sitting behind the host will ignore the alarm caused by the other one in exchange for half of those diamonds. When you mix these things together in a fashion like this, where the door contact goes here, so it goes to the host, but it also goes to the DMP panel, right? It goes to both. It's going to report to the guard who's sitting here, and then it's also going to report out to that third party. And normally the third party, you will give them camera access so they'll be able to look and see what's going on at this door. Then they will call the guard and say, hey, I got an alarm from that door. I don't see anything going on. What's up? I'll go down and check it. Okay, nothing here. We're good to go. Or if indeed the folks in this alarm monitoring center who got the alarm this way see something on the camera, they call the guard and they also call the police and they go in and say, what are you doing with a handful of diamonds, buddy? So you can put these things together, and for high value cargo or high value inventory, you're going to want to potentially have both, especially after hours, so that you know that your guard either didn't go bad or wasn't hit over the head and no longer can sit at the host, right? Somebody breaks in, they sneak up behind the guard, they pop one in him, and he's done, right? Now the alarms are coming here fast and furious because you're stealing everything out of all these doors and nobody's around to hear it. If you have it set up this way after hours, it will also go out to another place that can call. They get no answer, they send the police. So linking them together can be a very good idea if you have high value inventory. And if you don't want to have someone sit at a host 24/7, it will cut your guard bill down, right? Because you're just going to call the police if something happens, maybe on this. So, I recommend that you consider having a two-way setup when you install these things. And again, you can call this the DMP, the alarm panel. I usually call it a DMP panel because it's the one I use most. But again, that's a trade name. But any installer will know what you're talking about. And if you have questions on this gets a little complex in how you hook it up. If you have questions, please let me know because I'd be more than happy to talk you through it again. So we talked about supervision and supervising your alarm system. What does that exactly mean? Supervision tells you if lines are cut or if power is lost between the contact and any one of the panels, right? Either your DMP or your alarm board or even the host, right? It tells you if somebody's cutting wires and where that line might be cut. And what you do is you put a resistor in the wiring. It's just a small, cheap thing, and it holds a certain amount of energy. And when a line is cut, that is programmed to send in one last alarm. It's a cry for help to say, supervised line has been severed or been cut or been interrupted, however you want to word it, right? Because you put these narratives in yourself when you program your system. But it has just enough power. So normally you'd need to have power on these lines to communicate, right? So, it's power running from your alarm panel, either one to the host or to wherever. Somebody cuts the line, that's it. This allows for one last bit of energy to tell somebody that something's been cut. You should always supervise alarm lines, and installers have to be told to do so. And you should put it in a scope document that you give to your installer when you say, this is how I want it installed. Get that one in your head and keep it there for when you get out in the field. I want my alarms always supervised, because if not, somebody cuts a line, you will be embarrassed, and you'll be embarrassed at a very high amount of money every time, because that system was not able to give its last cry for help to say somebody just cut my lines. An unsupervised alarm point is just a false sense of security, because you really don't know. The alarm's not coming in, so therefore everything's good. Not really, because the alarm could have been severed and you just didn't spend that extra couple of bucks, and that's really what it is normally per line. Just a couple of bucks to have that put in there to have them supervised, but you need to do that on install, because it gets more expensive if you try to retrofit stuff. But just remember what supervision is and how important it is to the integrity of your system. So quick example, I've got two places here where I put red X's, and that's where I took my wire cutters and snipped the wire. If I cut the wire here, I will have a resistor on this line, and it will say, back here to the DMP panel, it will say, we have a problem, the line's been cut. And if this is connected directly to the host, it will say it here as well, and then the whole thing goes asleep. Now, if it's cut up this high in the system, you're normally going to know, because somebody's going to tell you, hey, I can't get into doors and I can't do things. A lot of times it will be connected to the power supply for the panel, which will knock that down, and you'll get alarms for that, right? It will sometimes interrupt things, even though these panels are intelligent and should be working on their own. That high up, you might have a problem. Down here, though, all it will really do is shut off the alarm to that one room. But if I can access this wiring, if my installer didn't wrap the wiring in armor or just didn't install it right and there's wires hanging out here, pair of scissors, cuts it. If it's not supervised, this will never be known. It will never tell the panel, tell the host, to tell the DMP, which way you've got your alarms going. No one will ever know it, and I can use a crowbar to open this door and be in and out, and no one would know it. Supervised system, that last bit will say, hey, I don't have any power coming up this line anymore. Tell me, I need to tell you that you've got a problem. So that's basically it for supervision, but it's really important. I want you to remember that, and you will see the word supervision again on a quiz at some point here, so remember that one. So I've used the term false alarm and nuisance alarm, and I'm specific about what those mean. And you need to understand them too, because if you're reporting things back, especially to someone who's doing repair on your system, you need to be able to tell them, if you can, which one it is. And the difference between a false alarm and a nuisance alarm. So a false alarm is caused by a system fault, right? Something in the system, there's a bad wire. There's a short. A piece of wire insulation is rubbed off. It's touching the metal door frame, and every time somebody walks in the room, the door shakes just ever so slightly, and it causes an alarm. Okay, that's a false alarm. Broken contacts, some type of malfunction of the system is a false alarm. Now, nuisance alarms are caused when somebody does something. The paper on the bulletin board, right, waving in front of that air conditioning. That's not a false alarm. The system is alarming because it's telling you that something is indeed changing temperature in front of me. It's doing exactly what you asked it to do. But it's just going to keep coming in, and you're going to keep going over there and pulling papers off. Those are nuisance alarms. Lawnmowers running outside, the glass breaks. A nuisance alarm. A broken wire on one of those window breaks will potentially cause you a false alarm. So false alarms require a technician to fix. A nuisance alarm usually requires you to teach people and train them. One of the best nuisance alarms you're going to find, or the most frequent one you're going to find when you're out in the real world, is on the night shift. You will seem to get alarms all the time from certain doors, and it's people who are going outside to smoke. They don't want to walk all the way around from their work area out to a smoking shack in the front at 2 o'clock in the morning. They pop out through an emergency exit. The door goes off 3, 4, 5 times in a shift. And you send a guard. By the time the guard gets there, the person's already smoked their cigarette, and they're back inside, and you can't figure out what it is. Eventually you find out that it's not a false alarm. You've alarmed that door, and it's doing exactly what you told it to do. Let me know when this door is opened after hours. That's exactly what you trained it to do, and it's doing it. It's not a false. It's just a nuisance alarm, and you need to train people that you can't do this. This door is alarmed, and therefore you're causing a hassle. When you do that, you're not allowed to do that. So know the difference between false and nuisance alarms. Again, another thing that you will see in the future on a quiz, and the terminology is really common in the field. When you call and you say, I got this door and I'm getting a lot of false alarms, then a technician is coming out expecting to find broken wires, broken contacts, something in the system that needs repair. If you call somebody and say, I've got, nuisance alarms, they're going to tell you, well, train your people better, or they may come in with a test to see what it is that's setting off that motion detector. It seems to be working fine when I test it, but I keep getting alarms, and they may find the nuisance for you. But normally a nuisance is something you can either fix yourself by seeing what's tripping the alarm, seeing what's causing it to do exactly what you wanted it to do just at the wrong time. But if it's false, you require a repair. That's the difference between false and nuisance alarms. Common points of failure with intrusion detection. Renovations. Somebody comes in and renovates something. They come in and they paint the door, and they paint over the door frame. They paint over your balanced recessed contact, that little disc in the top of the door. Sometimes that's enough to change the pull on the magnet and to cause failure. People come in and they put new window glass in. They put new frosting on glass, right? They put in new blinds on the windows, and they knock your window bug out of alignment, right? They put in new ceiling tiles, and they bump the wire on your dual technology glass sensor that you've got mounted on a false ceiling, right, in a room full of glass. Renovations are the most common points of failure. So when you have an area that's being renovated, when it's done, any type of renovation, be it painting or changing ceiling tiles or new carpet, whatever it is, if you have an area that's renovated and it has alarm contacts in it of any kind, test those after renovation. One of the other common points of failure is that these can be turned off, normally in the host, but you can go into the host, just as you could turn a badge on and off, you can turn an alarm on and off. And it will drive you crazy because somebody will be tired of nuisance alarms and they'll just shut it off. And then that is the place where you will have a break-in or a problem or an intruder at some point that didn't get detected. You need to have alarm testing. And you need to understand nuisance and false alarms again, and the difference between the two and what may cause them. But alarm testing is the key to taking care of these common points of failure. And real quick, let's just talk about alarm testing before we bug out for the day. You should have a set and structured alarm testing protocol. How are we going to test this alarm? Well, if it's a door position switch, right, a read switch on a door, I'm going to have somebody open the door. If it's a badge reader door, I'm going to have them use their badge, open the door, and the alarm should not come in, right? Because we've got it programmed correctly, and the alarm should not come in if I use my badge and it works. Then I'm going to have somebody force the door. I'm going to use a key on it. I'm going to open it from the other side. Somehow I'm going to open that door without my badge and make sure the alarm comes in. You set up a protocol for how you want every one of your alarm sensors tested. How are we going to test the glass breaks? We're going to use a tuning fork and we're going to shake them. We're going to use a device that slaps against the glass that gives it the right vibration so it sets these bugs off. We're going to have a guard walk the fence line and walk in and out of the microwave beam between every sensor and make sure that it gets set off. You have a structured testing protocol and you do it on a regular schedule. If you discover that your alarms weren't working after you have an event, a break-in, and you find out that you could have tested this and in some cases these things weren't working for months, it is your worst nightmare. If you are a security manager and you have security guards, if you have a big alarm system, you're probably going to have guards. But if not, during the day, once a week, you go walk it and test it yourself. You verify the tests in the system history, because when it reports either to the DMP or the host or to both, it will make a record of it. It'll be in the history right there with the card transactions that I went in and out of the room at this time. The alarm history also says the alarm tripped at this time and it reset at this time every time it goes off. So you either check your own history to make sure it worked. If you're walking it all by yourself, you go test all the alarms and you go back to the host and look to make sure that they all came in. Or if it's a third-party monitoring service, you set up a schedule with them to say, on Tuesdays at 2 o'clock, I'm going to walk these alarms. I need somebody. I'll be on my cell phone. I'll need somebody to tell me, yes, it worked, and no, it didn't. Keep those alarm testing records, either the history in the system or a paper record that you did it, or had the third party mail you the results of the test every week, so you email them so that you can keep them. But make sure you have those records because in the event that an alarm fails, you want to be able to show that you had due diligence at least every so often on your set schedule that you went out and tested those alarms. And I would consider hiring the installer to conduct the testing. If your budget allows for that, at least in a service contract with an installer for your alarm system, and especially if it's a third party that's monitoring and put it in for you, right? The ADTs of the world will install these third party systems, these standalone systems, and they will monitor them for you. put it in the contract that they will come out at least every couple months and fully walk test the alarm. If your budget allows for that, that gives you that sense of insurance that your alarm will work in the event something goes wrong. And if it doesn't, at least you'll be able to go back and say, I've tested it on a regular basis. This was a fluke. And that'll be your get out of jail free card. So always make sure you have alarm testing protocols in place. So key takeaways this week. There are two types of alarm systems in buildings, the integrated and the standalone. Integrated is generally self-monitored because it's going back to your host. If you use a standalone, it's generally monitored by an outside agency. Not always, but generally that's the methodology you use. You really wouldn't need that standalone unless you had high value inventory that you wanted to go to two places after hours perhaps. But generally, if you put a standalone panel in, that DMP is going to report someplace else. Otherwise, it's coming back to your host and you're going to self-monitor, right? And that's expensive because you have to pay for the manpower, but you don't have the monthly bill for monitoring. Both of these types of systems run off the same types of sensors or contacts. And doors are normally reed switches of some type, right? Plungers are for drawers primarily, closet doors, small doors, right? That are, passage set type doors, quite frankly. Something on a cabinet that has a swing door on it, a wooden cabinet on it, you could put a plunger switch. But reed switches on doors, either the recessed or the surface mounts. You're going to use PIR in open hallways and open areas. You're going to use microwave sensors on the outside, perhaps, of your building. If I refer to something as a DMP or a Bosch panel, then it's a standalone panel. You can call it a standalone. You can call it a standalone alarm panel. Whatever floats your boat, I'm fine with. But if you call it a DMP or a Bosch, I'll know what you're talking about, and generally anybody in the industry will. Make sure you know what supervision is, right? That resistor in the line that gives that last bit of information that says, I'm in trouble, come help me. Make sure you have a good idea of what types of sensors you might use in what type of application. That's really the key to sensors and to an intrusion detection system. If you use the wrong type of sensor, I've seen people put PIRs on doors. They've essentially put them inside the door, pointed at the door, and when the door swings open, it'll cause an alarm. Yeah, that works, but why would you do that, right? Match the door. If it's a swinging door and on a man door, if you will, a regular door, you're going to use a reed switch of some kind. If it's a cabinet door or a cabinet pull, you're going to use a plunger. If it's outdoors along a fence line, you're going to use microwaves. And if it's hallways and open areas indoors, you're going to use a PIR. Those are really the four main ones. Make sure you know how to match those up. Know the difference between false alarms, alarms that are caused by something faulty in the system itself, and nuisance alarms caused by people or things that are just triggering and telling your system to do something that you've asked it to do, just not as often and not because of that. Know the difference between those two, and then also understand alarms don't work are really a big concern. You need to test them, have a standard testing protocol, a testing pattern and time frame, and keep records on those tests. Okay, our projects. So we have done the door hardware schedule, the section on what lock sets you recommend, known as the door hardware schedule. Okay, you've determined what doors may need access control, what type of credential we're going to use. We're still deciding on the credential. We'll talk a little bit about biometrics, but I would not suggest that you're probably going to use those. It's probably going to be a badge on this type of building that we have. And how many panels you're going to need. We are using 2 door control panels are our model. Again, there are bigger ones out there that can handle more doors, but we're just using called a Mercury MR52 2-reader panel and not connected to any other intelligent panel, just going straight back to the host. We've done that part, and we put them on our drawings, and the vast majority of you had those pretty much down where you want them. You're making some small tweaks to them, and that's fantastic. You should continue to do that. If you think something might just be a little bit better, just move it around somewhere. Those who are not getting it, I'll have conversations with you this week sometime so we can get on the same track, if at all possible, but don't fear. I'll be working with those of you who are not quite getting it, but for the vast majority of you are getting this really, really well. This week, you're going to consider where you're going to put alarm sensors and what type of system you'll use. Think about who might monitor it, right? Are you thinking about having guards 24/7? Does this building warrant it? You know what's going to be stored there? Maybe that's a good idea. Maybe it's not a good idea. Maybe you'll want to have dual monitoring after hours when all the employees go home if we're not going to run 24/7 for a while yet. Think about that. You're the security manager. You need to design this. Are you using a mixed system? Are you going to use one specific type? You determine that, and you're going to plot it out. The instructions are on the discussion board. And this week you'll also have some actual narrative to fill in, and you'll have comments to make on the designs of others, but you're going to put it on that same plot. You're just adding and you're overlaying the different components. We've done door hardware schedule, we've done access control, and we've done our panel model. Now we're going in, we're doing our intrusion detection system. So this week, hopefully you've already read the text chapter 8. It's not a long chapter, but it's got some good stuff on it under glass, right, about glass, which, it's really short, but it's good information for you to know. And then there's the terminology of the different alarm type contacts that are in there, and intrusion detection systems. You'll notice terminology differences between what I say and what they write. I don't know anybody that uses balanced magnetic switches, BMS, anymore. Balanced contacts is generally the term that's used, or door position switches, DPS. But everybody uses a little bit different terminology. That's to be expected, right? There's a lot of things where we use different words for different things, and this is just one more thing in industry. So get used to that. As long as you know that they're interchangeable. A shock sensor and a window bug are the same thing, right? It's that little square that goes in the window. Just get used to that. You sat through my lecture for 56 minutes, and I appreciate that very much. Design your IDS on your existing drawing per the instructions on the discussion board. That's due on Thursday, always at 11:59 p.m., 1 minute before midnight. And there's a design and some narrative that's due. It's in the discussion board. And then Sunday night, 11:59 p.m., responses to 2 classmates are due, and they are specific as to what you need to respond to and what you need to discuss with them. So please read the discussion board on that. With that, we are done. Have a great week. If you have questions, I am available all week, and I look forward to hearing from you if you have those questions. Have a great week.